Dear students, a warm welcome from me, myself Rahul Ko. Today we are going to discuss syllabus of robotics subject under professional elective 4. As you can see, the teaching scheme for this subject is 3 lectures per week and practicals 2 hours per week. The examination scheme for this is very similar which we faced last time in COVID situation. Test 1 13 marks, test 2 30 marks, continuous assessment 20 marks, skill and competency exam 20 marks, practical and oral for 20 marks. The total credits for this subject is 4. The prerequisite of this subject is mathematics, control system, basic embedded system and basic programming. So all these subjects basic knowledge is required. Now this subject is the combination of all domains like control system, embedded system, power electronics, then mechanical system. So there are various streams which are include these number of subjects in their curriculum. So you can just go through it, graduation at PG level and at post PG level. These are the branches which are included these subjects as a major subject, because as we know the automation nowadays is an essential part of the society. That means every in day-to-day life, if you go through, there are a lot of automation you will find around you. To fulfill this automation, we need a skilled persons, right? To design a new system, to refurbish the system, to replan the system. Okay, we need skilled persons, and these skilled persons should have a knowledge of robotics, right? Now, whenever automation word comes, very first thing comes in mind is control system, and then actuators, then sensors, and then electronic system, and so on, right? So of course, to understand the automation, we should know about the robotic system. The robotic system included in a BTech level, MTech level, on PhD level. In BTech level, the subjects are incorporated in different branches, like in electronics, mechanical, electrical, computer. Whereas in PG level, specializations are designed, like MTech in robotics, MTech in cybernetics, MTech in automation, MTech in path planning and navigation, MTech in AI. As you know, in our university also we have AI and DS branch, which is newly open, and it currently dealing with artificial intelligence and data science, which includes various algorithms, right? The further MTech specialization can be extended as an research topic for PhD, right? The literature shows around 20% of PhD is around robotics, right? So this is the major area where the research is now happening, and this research is applied research, which in turns developed so many theories which are used for the real world applications. Now, why this subject is to be chosen for academic, right? So for this I choose survey from Universal Robot Company, right? He did a survey and they found uh, these many companies which are working for automation. They have their own robots and they are doing automation things for, or they're developing automation in different companies, right? They are also working as a vendor company, right? And if you see the graph of automation in the industrial market, in that case, China is the leading one, taking 140 points, whereas Japan 49 points. You can see India, which is at 9th or 10th position, right? Around 4.3% of automation is done. So we are very lagging behind China, and that's why the productivity of our country is less compared to the China, and we are very much depends upon Chinese products, right? So our country, that's why our country chosen make in India product and so on uh, to automate various industries and streams, right? So there is a lot of chances to have getting job if you preferred your career in robotics, right? The objective of courses are uh, is to understand mathematical modeling used in robotic architecture, is to understand basics of robotic operating systems and its architecture, to understand what is ROS and how it can be used in real life with the help of its structure like client, library, client and server types of communication. Then we have nodes, and these nodes may be publish the messages, and it also receives the messages, right? Now robot operating system is widely used uh, in most of the industries. They have like it is equipped with inbuilt simulator. Then it uh, includes robotic structures, also robotic models like URDF and uh, its simulation environment model SDF, right? This URDF is unified robot model, whereas S means simulation. In ROS, we can use RVs and RQT to check the interfaces, like the models whichever developed, how they are communicating with each other, and what type of messages are passed, and the connectivity of both all the models and dependability of the models can be visualized using RVs and RQT. That's the objective of our course. One more objective of our course is to introduce this ROS in a real world system, right? So we have a robot in our laboratory. So as our department purchased Dobot robotic arm and Firebird 5 autonomous robot, which is not autonomous, but it's a mobile robot which can be designed to work as autonomous through programming, and this part is achieved like we in this syllabus, in this subject we are going to design atomicity of that mobile robot, right? Then to understand the introduction of AI and machine learning algorithm in ROS application, as well as computer vision component in the robotic application. So when we introduce computer vision types of components, or you can say computer vision types of sensors in applications, then we need to synchronize computer vision sensors with the robot movement. So that type of synchronization it can be achieved with the help of robot operating system. Course outcome, these are designed according to the each unit. There are 6 course outcome. We'll go one by one. So once we complete each topic, we have one course outcome, right? So very first unit is Introduction to Robotics. Now in Introduction to Robotics, we are going to study robotics and its application environment. What is a robot autonomy, its definition, and history of the robotics, as well as terminology used for robotic systems. Then we'll see accuracy and repeatability of the robotics. Then few specifications of the robot according to the application, speed of the robot joints, links, robot classification, whether it is 1DOF, 2DOF, 3DOF, and so on. According to that, we'll see different parameters of the robot. Then architecture of the robotic system. How should be the architecture of robot for particular application, that we'll see in this unit. Then realization using different system components. That means to realize any particular part, if we want to extend a part of robot, in that case, whether it is feasible to extend that part to electrically, electronically, mechanically, like pneumatic system or hydraulic systems. Those are the component of realization components of robotic systems. Now at the end of this unit, you will understand basic robot systems and its system component. So for that, we are going to use different simulators, right? And we'll see some videos and some tutorials on different platform. Unit 2 is discussed about robot kinematics. So to start with robotic kinematics and inverse kinematics, we need to understand mathematical operations like vector space, inner product, vector norms, orthogonality, then linear transformation, matrix multiplication, matrix group, coordinate transformation, rigid transformation, rotation matrix, and quarantines. Kinematic chains, forward kinematics, inward kinematics. And for this, we are going to use open source software, which will discuss about how the kinematic system can be designed, and we can visualize the designing of kinematic system, like forward kinematics, inverse kinematics, right? Then the kinematics can be used for 2D and 3D transformation, right? That can be seen on visualization tools also, right? Then translation homogeneous coordinates, then multiple transformation. For the understanding of these points, we have 1 or 2 case studies. Now kinematics is nothing but how the robot performs operation, and how we can model that robot according to the applications, right? So for that, we need some mathematical tools, right? And mathematical operations to be performed, right? So we have some videos in this case, applications using that kinematics, right? At the end of this topic, you will understand role of mathematics and how we can describe robotic arms, robotic mobile robots by modeling it mathematically. Unit number 3 discuss about design consideration of 3DOF. DOF means degree of freedom robotics arm, and mobile robot system means autonomous mobile robot system. So in this unit, we are going to design a trajectory and control sequences to move the robotic arm or mobile robot in an environment, right? That can be done with the operator interface or without operator interface, that is semi-autonomous and autonomous type of systems. Then we'll see how the actuations are performed with open source simulation software as well as through the real world robot systems, right? As we have a robot in our labs, so that will help us to understand those systems. Then introduction of robotic application, we'll see through a few applications like material handling, object loading, unloading, welding, spray painting. We'll observe the operation of this, and we can find out or we can check how the different operations are performed, and those are synchronized, right? At the end of this unit, you will understand analysis, how to describe and analyze the fundamental of robotics, fundamental problems in robotics such as load to change and prior position of configuration of robot. For this we are going to use this is the robot which we have purchased, right? Then we have a mobile robot, Farbird 5. So these two we have practically we can see the functions of functionality and the operation of these two robots. Then we have simulation parts. So other robots we are going to simulate on simulation environment. Unit number 4 is the introduction of ROS, right? Now to interface, to operate those robots, we need a operating system or we need a programming system, right? So the programming system, for the programming system, we have a robot operating systems which we are going to install. And through this robotic operating system, we are going to actuate signals with the help of programming languages like Python, C, C++, and so on. Basically, ROS can be directly interfaced with C++, then Java, then Python. So we choose Python as it is very simple and a lot of functional libraries are available. So and it's easy to understand. So we choose a Python as one as the programming language for the robot. In this unit, we'll learn how to install ROS. What is the ROS architecture and its philosophy? Then what is the framework of ROS and how we can release the ROS? Then what are the masters nodes and topics in ROS, right? Then we'll see how the gazebo simulator is installed and how we can utilize that gazebo simulator under ROS environment. But before that, ROS is installed on Unix environment, right? There are two flavors of ROS. ROS can be installed on Windows and it can be installed on Unix, but it's very good to install on Unix because Unix, but that is Linux, is very close to the hardware, right? So obviously ROS, installing ROS on the Linux is much more recommended compared to installation of ROS on Windows, because in Windows we have lot of interdependency, right? Then you require licensing, right? Whereas Unix and Linux, they don't require any license and it's open source, so it's easy to install these open source softwares and use this open source operating system ROS over the Unix, right? Under Unix environment. Similarly, Python is also open source and we can use that as an most promising programming language, right? So the whole structure is open source at all. Like Python we are using for ROS, which is explored on Linux, right? The full chain is open source. So this is ROS environment, simulation environment. We are going to use these environments, right? At the end of this topic, you will understand an implementation of ROS for the robotic functioning, right? Then fifth unit is the realization or real world implementation of ROS based application, right? So here we are going to design ROS applications for ROS applications, or we are going to explore ROS applications. That is for Firebird 5 and Dobot, right? Dobot is a robotic arm in which the movement of the robotic arm is controlled through a ROS architecture or ROS, right? And then the different operations, like different types of applications carried out through the robotic arm, right? Now, one more application we are going to develop is designing a SLAM and robotic navigation using SLAM, using ROS, where we are going to implement scanning of different sensors like odometer, lidar, laser scheme, and representation of outcome of these sensors with respect to environment, right? So that part will we have in this unit, right? So at the end of this unit, you will understand how to implement ROS based application. And to implement this application, we require a lot of tools, right? And a lot of devices we are going to interface. So these are the different interfaces which we are covering in this unit. We have hands-on sessions in this unit. So obviously we are going to design systems. Maybe if time permits, we are doing it physically. If it is not, then we'll implement it on simulation environment, right? The last unit of this syllabus is AI, robotics and computer vision, where the computer vision sensors we are going to interface or we are going to integrate with the ROS applications, and we are going to synchronize robotic vision sensors with the robot movement, right? It's a very critical task, and this once the calibration of computer vision sensors with respect to robotic movement is done, then it becomes easy to operate the robots, right? So assembling, inspection, welding, spray painting, mobile robot navigation, that sort of application becomes easy once you have a knowledge and once you have understanding of interfacing of computer vision with sensors with ROS, right? At the end of this unit, we have AI robotics, that means machine learning based algorithm, which used to implement robotic applications, right? Now, in that case, we are using CNN based applications for robotic applications, right? We have 2 case studies under this. If time permits, we'll go for second. Otherwise, we have 1 case study based on machine learning, right, for robotic application. At the end of this unit, you will understand how to implement computer vision and AI based robotic application. So these are the few examples where these AIs and machine learning algorithms are designed and deployed. List of experiment, in that we initially installed Python RS. That will be our first practical installation of complete system and integration of all. Then very first we'll create the nodes for the robot, right, through the ROS. Then we'll do point-to-point movement of robot through ROS, controlling of 3 DOF based robotic arm, and implementation of implementation of robotic arm application like material handling will do using ROS. So all these operations will performed on Dobot robot, right? One more application we are doing on robot is object loading, unloading assembly using ROS. At the end, the two application is based on, one is based on the autonomous robot. We are trying to design an autonomous robot based SLAM method, means self-localization and mapping. And at the end, we have a machine learning type of algorithm for robot navigation. Right? Now in that, at the end of this subject, we have one PBL which is based on designing a robotic system for developing a real world problem, for solving a real world problem. In this case, we are going to use most of the algorithms which we are going to study in this subject. We are going to use ROS in this case, right? And we are going to implement one system, which is the solution for the real world problem, right? The books for this subject is this, right? Textbooks and reference books. Then these are the front pages of those books, right? These are the simulation softwares. I'm assuming you are going to select this subject as a career path, right? And I wish best of luck for you. Thank you.